Hey guys, I'm thirsty. I'm gonna get a drink of water at Walgreens.
Oh my god, I think you drank dirty water. You should have used a better filter.
Filters don't do their job as well as they're supposed to, as well as everyone thinks. Maybe you should use our new filter. It uses advanced technology to filter water using carbon nanotubes.
Here, try some water from CleanWater for you. Yes.
This feels pure and healthy. It sure does.
Has this ever happened to you?
What happens to my friend all the time?
With CleanWater for you won't have to worry about getting sick from dirty water ever again.
A normal water desalinate uses reverse osmosis to desalinate water. Reverse osmosis is when large ions are separated from solute by adding pressure. The solute and solvent are physically separated through a semi-permeable membrane. Do you have any idea how much energy this device uses?
Also think of a normal water purifier that uses heat to kill microorganisms before we drink the water. This too uses an enormous amount of energy.
What if we told you we can combine both of these attributes into one filter that uses 75% less energy than both the filters combined?
Wow, that's a lot.
Well, with our product, using the state-of-the-art nanotube technology, we could achieve this.
The new filter works because it contains billions of tiny nanotubes that are catalytically grown in labs.
Water is poured into the container holding these nanotubes that are vertically held on the bottom of the container. Due to a property of these nanotubes, the ions and microorganisms are physically separated from the water molecules. This process is called size exclusion filtration. The nanotubes are so small that the only thing that can pass through them are polar water molecules that fit in the tiny diameter of the tubes. The toxic ions, gases, and other bacteria are just too big to go through. Also, through a property of the nanotubes, the ions and other microorganisms actually are absorbed by the tubes, making their passage through the tube virtually impossible. The carbon nanotube is covalently bonded in a cylindrical arrangement of carbon atoms. All the carbon atoms are bonded in a trigonal planar manner, which in other words is bonded by hybridized sp2 bonds. The reason why the carbon nanotube is such a perfect filtration device is because of its size and strength. The carbon atoms are bonded by hybridized sp2 bonds rather than sp3 bonds, because graphite contains sp2 bonds and diamond contains sp3 bonds. The bonding in graphite is slightly stronger than the bonding in diamond. That's correct. Each carbon exhibits sp2 hybridization to form sigma bonds with 3 near carbon atoms separated by 1.4210 angstroms. 1 angstrom is equivalent to 0.1 nanometer. These bonds between the carbons within the layer are slightly stronger than those in diamond. Diamond, on the other hand, is bonded by hybridized sp3 bonds. The bonding of diamond is a little weaker than the bonding of graphite. In diamond, each carbon atom is bonded to 4 other atoms by sigma bonds, and the distance between each bond is 1.5445 angstroms. The bonding length for diamond is slightly larger than the bonding length for graphite, which would make graphite slightly stronger than diamond. CleanWater for you does require a little energy, however, it requires much less than the normal filters used today, making it non-spontaneous. This would lead to a delta G being slightly positive. Yes, there has to be little energy required because someone has to actually pour the water into the filter, requiring a little work. The delta S of this process is slightly negative. This is because the aqueous ions become solid or liquid, representing less disorder and effectively decreasing entropy. The process works by harnessing the potential energy of the oceans, waterfalls, and large bodies of moving water. Similar to hydroelectric dam,
The water, instead of rotating a turbine, will push through a layer of nanotubes, which will automatically clean the water by removing the contaminants and the light.
Wow, this is so cool. Where did I get one of these?
Well, we only sell large machines to governments and water plants. The actual price of this technology is $10 million and 99 cents, but in the long run, the benefits outweigh the initial price. This is the reason why we have to sell our product only to large corporations, because they are the only ones with the capability to distribute clean water to all below the poverty line.
But it's okay. You can just make your own. It's really easy. All you know is chemistry. Oh, I don't know chemistry that well.
Well, maybe you should take AP Chemistry at Evergreen Valley. I can introduce you to my teacher, Mr. Walls.
Nah, I'm taking it over the summer at BBC.